Question 6 bears more than a passing resemblance to a Maths Watch question you completed a few weeks ago. A number of you will be able to do this in your head, but for those of you that can't, I'll talk through a slightly more analytical method. Pfizer has 10 coins in a bag. There are 3 £1 coins and 7 50p coins. Pfizer takes at random 3 coins from the bag. Work out the probability that she takes exactly £2.50. So there are 3 rounds of choosing coins, 1, 2 and 3, and in each case there's a binary possibility set, either £1 or 50p. So that screams to me tree diagram. So I have either £1 or 50p, and then equally those branches will split into a further 2. I'm never very good at drawing these. Another 2, another 2, another 2, another 2. That's actually not too bad for me, but I'm sure you can do better. I'm going to label everything up so that I don't get confused, and I'm going to make sure that I'm consistent in £1 always being at the top, just because it makes it less likely for me to make a mistake in my calculations. I then need to write out my probabilities as well, and I'm just going to pay particular attention to the question. There's no indication that the coins are put back in the bag after they're chosen, so this is a without replacement problem. There are 10 coins, 3 of them are £1 coins, so that's nice and easy. I have 3 tenths, and therefore there are 7 50p coins, so 7 tenths. I wouldn't bother simplifying probabilities at this stage. On my second choice, if I've already taken £1, there are only 2 £1 coins left out of 9 total. And equally, there are still 7 50p coins out of 9 total. I can just check those values make sense by adding them up and seeing that they equal 1. And then if I've taken another £1 coin, then I have £1 coin left out of 8 total, or alternatively, still 7 50p out of 8 total. If I took a £1, then a 50p instead, I've got 2 £1 coins out of 8 total, and I've got 6 £1 coins, 50p coins, sorry, out of 8 total, because I've taken 1. Exactly the same principle here. If I take 1 50p, I've got 3 ninths and 6 ninths. I've taken a 50p and a £1, I've got 2 eighths and 6 eighths. I've taken 2 50p's, I've got 3 eighths, and I've got, whatever that leaves me with, 5 eighths. And I want her to take exactly £2.50. So there are 3 possible paths for that. Either £1, £1, 50p, or £1, 50p, £1, or 50p, £1, £1. And because it's or, in each case I'm going to add those probabilities together. Every time there's a new way of doing things, it becomes more likely it's going to occur. So £1, £1, 50p is 3 tenths times 2 ninths times 7 eighths. 3 tenths times 2 ninths times 7 eighths. Then £1, 50p, £1 is 3 tenths, 7 ninths, 2 eighths. 3 tenths, 7 ninths, 2 eighths. And because all these are happening, I'm multiplying those probabilities. And then my final possibility is 50p, £1, £1, so 7 tenths, 3 ninths, 2 eighths. 7 tenths, 3 ninths, and then 2 eighths. I can just type that all into my calculator. My fraction button makes this slightly easier. And this is the line of working I would expect to see. I said at the beginning of this question that you can do it in your head just by thinking about, well, how many total coins have I got left, and how many of the coin I care about have I got left. And this is the line I would expect to see if that were what you were doing. It's taken me longer than I anticipated to do this, but it's marginal in terms of the time cost in an exam, so I'm not overly worried about that. 2 eighths, that is not how to do that. 2 eighths, and I close my bracket, and I have my answer of 7 40ths. It just wants a probability, so that would be fine, or I could write that as a decimal, which is 0.175, and that's question 6 sorted.